All right, so this is a continuation of 4.1 to 4.2, dealing with PDFs, which is probability density functions, which are continuous, and then moving that into the realm of the CDF, which is the cumulative distribution function. So we have this first problem that says, or actually this is our second problem. In commuting to work, a professor must first get on the bus near her house and then transfer to the second bus. If the waiting time in minutes at each stop has a uniform distribution with A equals 0 and B equals 5, then it can be shown that the total waiting time, Y, so notice we're having two stops here. So it's 0 to 5 seconds for each. So 0 to 5 seconds for the first stop, and then you'd be 5 to 10 seconds because you got to add another 0 to 5 for the second stop. So we've got this PDF right here. So we've got it broken down into pieces. We have 1/25 y if you're including 0 up to 5, but not including 5. 2/5 minus 1/25 y for between 5 and 10, both included in points. And then 0 if we're less than 0 for y or greater than 10. So now the first thing is they want you to pick the graph. So if you think of these as kind of linear equations for a second, or functions. So you know mx plus b, that's the slope. There's only one graph that even makes sense with the slopes we're given. This is a positive slope and this one's a negative slope because the slope would be near the variable in that format. So that we need to be going uphill from 0 to 5 and then downhill from 5 to 10. And the only graph that does that is this one. And notice even the growth of that rate of change is similar. It's just one is positive and one is negative. So it's that first graph right there, or the last graph right there. Okay, so we're going to use some of that empty space up here in just a second, possibly to do some calculations. We'll see if we need it. So now we're wanting to verify that from negative infinity to infinity, f of y dy equals 1. Now that is based on the fact that we are trying to prove that it's a valid probability distribution. Now, even though we don't have a function that is defined everywhere in terms of like it's 0 everywhere that's not 0 to 10, so we're going to break it up into two separate integrals. So 0 to 5 for 1/25 y dy plus the second half is 5 to 10, and it's 2/5 minus 1/25 y dy. So we're going to integrate both of these. This first one would be y squared over 50, and that's from 0 to 5. So that's what we're going to fill in right here. The second one is going to be, we'll have 2/5 y minus a y squared over 50. So we're just doing our power rule, and that one's from 5 to 10. So we'll fill that in here. Okay. If we evaluate these using the, remember, large F limit, the fundamental theorem of calculus, essentially, this one would be big F of 5 minus big F of 0 for this one. So that's going to be 25 over 50 minus 0 over 50. So that's just going to be 25 over 50, which is 1/2. Okay, so that's what we got here. They already got that one. And then we have the second one, which is big F of 10 minus big F of 5. So that's going to be 2/5 10 minus 10 squared over 50 minus, and then we'll have 2/5 times 5 minus 5 squared over 50. So we have to work these out. 2/5 times 10 would be 400, because 10 squared is 100 minus 50 would be 2. And then we're going to have minus, a second parentheses will be 2 minus 1/2. And so what we get for that is 2 minus 2 plus a half. So this equals a half. We can put that in there, and that is a half plus a half, which is 1. Now, when we're doing the probabilities down here, we're integrating, and we're either going to be going from, say, 0 to a number or 5 to a number, or we could be going from a number to 5 or a number to 10. It depends on which function it falls in. Sometimes you might go between both pieces and you have to do addition of two integration parts. So let's look at our first one. It says the probability that the total waiting time is at most 4. So that's the probability that our y is less than or equal to 4. So that means we're going from just that first function part because it went from 0 to 5. And so we'll be doing the 1 over 25 y dy, which we already know what that is. So we already have that big F. that big F of y for this portion was y squared over 50. So we already know that. So that's functioning for anything from 0 to 5. So all we need to do is go big F of 4 minus big F of 0. So that's going to be 16 over 50 minus 0 over 50. And if you divide 16 by 50, you get 0.32 for the probability. Okay. Now we're looking for at most 9. So at most 9 means 9 or less. Now that's going to be two separate pieces. We'll have the 0 to 5 for the first part, and then we'll have from 5 to 9 on the second one. And I'm just writing the original functions here so we can see how those integrals would have broken down. We're going to use the big F's that we came up for each part. So the big F for this one, remember, is using the antiderivative, which is y squared over 50. The big F for this one, so I'll call it F star just to be different. That's going to be that 2/5 y minus y squared over 50, okay? So for the first one, you're doing f of 5 minus f of 0. That one is going to be, let's see, 5 squared would be 25, so that'd be 1/2 minus 0. So this first part's going to just be a half, and then we'll have our plus. And then for this one, we have to do both. So f big star of 9 minus f big star of 5. So if we plug in 9, we're going to get 18/5 minus 81 over 50, and then minus, and then we'll have 2 minus 1/2. Okay. Now, if you work all of that out, this one ends up being, uh, let's see, I had it somewhere. Yeah, I got 24 over 50, I think, when I worked it all the way out. So that's going to be 0.5 plus, this is 0.48, so that ends up being 0.98. So you'll just need to work that out on your calculator. Okay, for part E, so I'm going to write that one down here. We're doing between 4 and 9. So between 4 and 9 would be from 4 to 5 of the first part. I'm just going to shorthand. And then we would have from 5 to 9. Now, we already did the 5 to 9. We did not have the 4 to 5 worked out individually. We had 0 to 5. We had the whole thing. So the 5 to 9 we just did a minute ago. That was the 0.48. That was this one we just came up with using our F big star. This one will have F of 5 minus F of 4. So that's 25 over 50 minus 16 over 50. That's going to equal 0.18 when you work it out to a decimal. So if you add these two together, I get 0.66. Okay. And then this one is, what is the probability that the total waiting time is either less than 2 or more than 8? So that's going to be from 0 to 2 of the first half, because that's that piece part. And then you'll have from 8 to 10 of your second half, which again, we have functions for each of these pieces. So this one would be f of 2 minus f of 0, plus this one will be our f star antiderivative of 10 minus f star derivative of 8. And when I worked this one out for this first part, I got 0.08. So that was this one. And for this one, I got 0.08 as well. And that's because there's symmetry. This is a 2 unit on the very far edge of the graph we had, and this is 2 units on the other very far side. There's symmetry at the line 5, that picture we had up above. So notice that we do get some symmetry here. Okay. So then that leads us to our last one in the 4142. This one already gives you, be very aware, they have given you your big F function. This is the CDF, not the PDF. So these are actually what they got as their antiderivatives for those specific limit groups. So all we're doing is just plugging it in. So for this one, the probability that x is less than or equal to 3, Well, that's in this 0 to 4 range. So we're going to do our f of 3 minus f of 0, because this goes from 0 to 4, and we're looking for 3 or less. So that's going to be 3 squared over 16 minus 0 squared over 16. And we work that out to a decimal. We're going to get 0.5625. And they wanted us to go to 4 decimal places. Okay. For this one, you're going to be doing f of 3 minus f of 2.5. If you look at that formula-wise, that's going to be, again, 3 squared over 16 minus 2.5 squared over 16. Since we're going to decimal form, all you need to do is work that out. So that's going to be 0.1719 if we go to 4 decimal places. This one's greater than 3.5, so that's going to go from 3.5 to 4, because that's the cap on that part. So we're looking at f of 4 minus f of 3.5. So now the 4 though is this part. It's actually equal to 4 when you get, that's full probability. You've reached the whole rest of the area. So that's 1 minus the f of 3.5. So that'd be 3.5 squared over 16, because we'll be using this one for 3.5. And when I worked that out, I got 0.2344. So since all of these are asking you to go to decimal form, you might as well just work out the problem on the calculator. Now, what is the median checkout duration? So this is the little mu symbol, but with the little tilde on top, that means median. So you're going to set your function of f, big F, of the mu with the tilde, that's median, equal to 0.5, because the median is at the 50 percentile point. So we're going to put 0.05, or excuse me, 0.5, writing and talking. So 0.5 equals big F of mu tilde, where we're going to plug in, and that would be mu tilde squared over 16. We'll multiply both sides by 16, so that's going to be 8 equals mu tilde squared. And then we're going to take a square root to get mu tilde. Now, when you work that out on your calculator, that square root, you're going to get 2.8284. That is the median checkout duration. And that would be in, looks like X was denoting the amount of time a book on a 2-hour reserve is actually checked out. Okay. Now, how do you get the density function? Well, if you want the density function, the PDF, the little f, you take the derivative of the antiderivative. So we're looking at from 0 to 4, we have to take the derivative of this. So we need to take f prime of this. So you're doing big F prime, where this is big F. Okay? So big F prime would be you pull the power to the front. So that'd be 2/16, and then we subtract 1 from the power. This is just going to be x over 8. So that was what this was before they integrated it. So that was from 0 to 4 and 0 elsewhere. Now, e to the x, this is a little tricky because you have to know how to do these. The formula for e to the x when we're dealing with these continuous distributions is that you take the derivative, or not the derivative, sorry, the integral from your domain, which is 0 to 4, and you do x times your f of x, okay, dx. So that's how you find e of x. And if you think about it, this is probability, and this is x. So it's like x times p of x when we were doing expected value. So it makes sense if you think of it that way. So since my f of x, my little f of x is x over 8, I would be doing the integral or antiderivative of, so this is x over 8. This would be x squared 8 over 8. So, and then that would be dx. Okay, so we're going to take the antiderivative of that. That's going to be x cubed over 24. And that would go from 0 to 4. So then that would be 64 over 24 minus 0 over 24. And when we work that out to 4 decimal places, this is 2.6 repeating. So it'd be 2.6667. Because you round that last one. Okay. Now, if you want the variance, you can use the shortcut method. Variance is e of x squared minus e of x squared. Okay. So that's a nice thing about that, is that you can use that. Now, we need the e of x squared then. So e of x squared is the same thing you just did here, except you're going to put an x squared in instead of an x in front of your f of x. So it's just essentially you're adding one more to the power when you do this antiderivative process. So that would be x cubed over 8 dx. So that's going to be x to the fourth over 32 from 0 to 4. And that's going to be 256 over 32 minus 0 over 32. And I got that that came out to exactly 8 because 256 divided by 32 is 8, and that's just 0. So now we can plug these in to find our variance. So we have this one is just 8. I would put this one in its fraction form. You don't even have to reduce it, but instead of rounding too early, let's just go ahead and put it in as its fraction form and square that. When I worked this out on my calculator, I got 0.8889. It rounded. So this is my variance. Okay. And then we take the square root of that. It's really just 8 repeating. So you could just say square root of this in your calculator, and that gives me 0.9428. So there's my standard deviation. So remember, standard deviation is the square root of the variance. Okay. Now it says if the borrower is charged the amount h of x equals x squared when the checkout duration is x, compute the expected change. Well, this is e of x squared. We just did that when we did our shortcut method. So it's that answer we got right there. It's the 8. Okay, that's it for 4.1 to 4.2.